Okay, so our next step is to think about how we can use this low-level HTTP knowledge to build or to design APIs for communication and collaboration between a client application and a server. Okay, so we start seeing our overall web application as a combination of a web front end, that will be our JavaScript React application, that needs to communicate or to exchange data or to store data or to read data from a database that stays on a backend, on a web server, somewhere else in the world. And we should design how these two communicate, how they exchange data and so on. The idea behind HTTP-based interfaces is that all the information exchanged between the application and the server is always encoded in JSON. Nowadays, maybe 10 years ago, it was XML, and in 10 years, I don't know, but currently, JSON is a good format for exchanging data. And all the operations and the endpoints that we need to call are mapped to different URLs. Okay, a URL represents an operation, a read operation, a write operation, or whatever, that the server provides. And the parameters in input and output from this service are encoded in JSON. Okay, I will skip information about JSON syntax just by saying it's the same syntax as JavaScript with some extra constraints that all keys must be quoted and there's no shortcut for quoting them, but it's a syntax where you can represent strings, numbers, objects, and arrays. So every complex object in JavaScript may be mapped, serialized in the syntax very easily and can be read back in JavaScript also in the same way by using these two methods. Okay, JSON.stringify takes a JavaScript object and returns a string that contains the serialized representation of the object. And parse is the other way around. It takes a string as an argument and returns a JavaScript object corresponding to the parsing of that text. So these JSON.stringify and JSON.parse functions are in the standard library, so you can call them both in Node.js and in the browser. Okay, coming back to this idea is that all these URLs represent something, some data that is stored in the database. We don't want to exchange SQL queries between the client and the server. So we want to have an abstract representation of the operations that we need to ask the server to do for us. And the idea is to map all the types of objects that the server is managing into URLs. And what kind of objects do we have in a server? We have individual objects, so the record for a given user, or collections of objects, all the users, all the questions of a given user, and so on. In a very abstract way, we can imagine every database as a list of collections and items of each of these collections. Then, of course, the database is very much optimized with foreign keys and everything else. But from a very abstract point of view, we can represent the information in this way. And so, for example, if you had a database representing university data, you would have a collection of all the students, or a collection of all the courses. So we can imagine representing that abstract concept, the collection of all the students, with a string, with a URI. So we are mapping abstract concepts into URIs, and why URIs and not any other type of strings? Because then we will map them into something executable. And this URIs will be a concrete representation, a concrete endpoint for doing operations on that abstract concept and that collection. We will give ourselves some rules to do that in a systematic way, in an ordered way, so that we will have a set of URIs that describe the type of objects that we are supporting, and use the HTTP verbs to describe the type of operations that we want to do onto these objects. Okay? So, at the highest level, collections or items. Collections are just a URI representing a category. Normally, we suggest is to use some plural names. And each item is just some item which is picked out of a collection. A given user, a given student is one item of the collection students with a specific ID. So we can map them by a URI that reads the collection name / the ID of the object. This is the abstract representation of a given object, a given, in the case, students. Or for a course, we have the collection of the courses / ID of a course. Of course, since you're working with databases, everything should have a unique ID, okay? But this is a given. And the idea is to reason about which entities we have in our design. In our case, we already know that we have users, we have questions, we have answers, and we have lists of those. And so define some names for those, and then ask ourselves, what kind of operations should we want to do onto this data? Or some will be very easy. Add a new user, add a new question, add the new answer to a given question, and so on. You know, generic create, read, search, delete operations. Some will be custom. For example, vote an answer. It's not something that we can maybe represent in a standard way by normal read and write operations. Okay, it's a specific. It has a specific semantic, so we can do some general operations, some custom operation on those. So we map which operation we want to do. So we have the abstract representation of the entities, the collection of entities, and the operation that we want to do on these entities, standard or special operations. And then we map everything into HTTP. So the abstract entities are mapped into URI strings, and the operations may be mapped into HTTP methods. So if I want to read the information about a given question, I would have a get that receives as an argument the URI that describes that specific question, and returns a JSON representation of the properties of that question, and so on. If we want to add a new answer, I will have a query, the URL, sorry, that represents the question for which we want to add an answer, because the answer is not just a generic answer, it's an answer to a question. So I will have a query that represents a question, and they can use the post verb to add a new object of type answer to that question. So with a few simple rules, we can have a regular way of describing the information that we want to do. For reasoning about complex stuff like the answer of a question, we should extend our representation of objects, but also take into account relationships. So, for example, when I want to say students / ID is a given student, then I have some information about the student, which are scalar information, let's say, the name, the date of birth, and other information. But that specific student is also in relationship with other entities. For example, you are enrolled in a set of courses, or you already, you know, how to say, you already gave the exam to other courses. So there are different relationships between the student and the collection of courses. So the courses in which you are enrolled can be represented with your ID from the collection of students. Pick one and pick the courses, the relationship called courses, that will give all the enrolled courses, for example. Then we may have another relationship that we call passed courses, for example, which are only the courses that you already passed. And we'll give a different representation of this courses because you will also have the score and the date of the exam passing, for example. And also on the other hand, a URL like this, courses, ID, students, I will read it like taking the full set of courses, pick one with this ID, and check the students that are enrolled in this course. So normally, for expressing most concepts, we only need 3 levels. One collection, one ID, one relationship. And so we can express a lot of operations on the collection, on the item, or on the relationship by combining this way of expressing information with the 4 main verbs of HTTP. So now we are giving a new semantics to HTTP verb that was never intended, but now it's standard. So, for example, if I have the URI that represents a collection, and I do a get on that, I am reading the list of elements, all the questions, for example. Get/questions will give me a representation of all the questions. A representation of all the questions, what does it mean? It means a JSON representation, probably it will be a JSON array of, well, now we'll decide, of question IDs, or question objects with all the properties. Just be aware that get all the students will be a query that will never be implemented like this, because you cannot have a query that returns 300,000 records with full detail. Okay? So we also be careful about what we return. But conceptually, a get operation on a collection will return the list of items in that collection. We don't specify, we need to document the level of detail in which we are giving that. And on the other hand, a post operation on a list, on a collection, would create a new element, append a new element to the collection. It's the new operation. You take an object and you post it to a collection. Post increments the data. I wouldn't suggest doing a delete to a collection because it would wipe out all this, so I won't implement it ever. And the put operation on a collection is something that is also seldom useful, because if I had to interpret the semantics, I would say I would replace all the current elements with a new set of elements. Very dangerous. So on collection, usually you get the list or search this list, maybe with some filter that you can give as a parameter, or add. And single elements, what can we do? Okay, since you have the URL of a single element or a single student, you can do a get and get all the information about the student. Or you can replace, update some information about the student. A put basically overrides the property of an object with all or a subset of properties that I'm providing anew. Or deleting an element from the collection to which it belongs. Okay? So we can imagine mapping this to, this is a database about dogs, for example, that depending on the URL, whether the URL represents a collection or represents a single item, we will do different operations. Okay? So we can decide, have, say, a vocabulary of operations that we want to support, that we need to support in our application. Okay? This is just another example from the Google documentation that tests are the same thing. The internal rules of Google when they deploy and develop a new API server. They follow these sort of rules. They are not standardized anywhere. Okay, they're just rules of practice that come from the nowadays standard interpretation of the HTTP verbs when they are used for accessing remote resources. And the same is for collections. If I have a collection like this, imagine I'm doing a get on this URL, so I'm getting the list of all the courses that you are enrolled with. If I'm doing a put on this, a post on this is a collection, doesn't support put. If I'm doing a post on this, I'm enrolling you to a new course. Or for enrolling you to a course, I could do a post on the list of courses for the students with an object describing the course. Or I could do a post on the student's collection of a course by providing the ID of the student. It's two ways of seeing the same thing. Adding an element to a relationship, and the relationship can be seen from the student point of view or from the course point of view. In the database, it's just a table that you can read it either way. Okay, so of course we are not mapping this into separate tables or separate relationships. They are the same relationship, but we are interpreting them, navigating them in different ways. Then from an implementation point of view, it would be just the same relation, many-to-many relationship between students and courses that we are managing or querying. Okay, so these are just, let's say, general rules. If you want, there are a lot of guidelines, that some of them are linked here, that tell you how some companies are telling their own developers to use these rules for having another way instead of, so that everybody is not inventing their own way of designing API. I have a rule for helping me to design the server side, and it also helps me when I'm calling a remote API, because I already can tell from the name of the URLs how they are used. And how to do this in Express is quite straightforward. We just register the routes that we need with the methods that we want to support. And it will be something like this. For example, get on a collection. Give me the list of elements of a collection. So I will register a get method on a collection-like URL. And internally, what I would do is call some methods for giving the list of answers. Here I'm imagining a DIO like a data access object. So the object that contains all the methods for accessing database. That is that I need to create somewhere, that has a method list answer that will return a promise with the list of answers. So in the then, I will just create a JSON representation of these answers and return them. So it's very straightforward implementation. Of course, all the work will be inside this list answers method that will query the database and compose the objects, create the array, and so on. Okay. And if you want to get a single element, I could imagine a URL like this. Always a get, always on the answers collection, but by providing an ID. And this ID would be a parameter, request.param.id. Remember, params extract something from the URL. And call a method for querying database on this ID, on this table, and return this answer as a JSON object. Of course, everything is asynchronous here. Remember to do some validation of the ID and so on, because it's an external data. And also to manage errors. And the same when I want to add something, for example. Adding something means posting to a collection. So I register a post. You see the URL always answers. In this case, with an appended ID, in the other case, it's just bare. Depends on the methods, get, depends on the presence of the parameter. If it's a post, then I would expect the body to contain the JSON representation of an object, and I pass this object to the a create answer method that will extract the method, create a query, and do the insert. Maybe by checking extra information or whatever. So these are very simple, nearly cut and paste methods that help us to make a concrete implementation of the abstract operation that we want to provide onto our data. Of course, there's all the, what is that? The error checking issue that, of course, we need to validate the data, and we should also provide a way for an HTTP method to not just return the result, but also return an error message in the case something goes wrong. So we can decide the HTTP status code, maybe 500, when something happens, and we can standardize on some sort of error object. So if an error occurs, instead of returning the data, we return also some explanation. Okay, it's fine having the error code, 500, something went wrong, but on the client side, how do we handle this error? We need to explain to the user what happened, and so we need some extra information. So maybe this is just, there's no standard here, we just invent, is an error code just a string, or is it some structured object that we decide, and in our application we decide how it's represented. So these are just guidelines. Think of applying them to our Q&A server, okay? So try to imagine defining a set of APIs for the main operations that are needed on the question and answers. Okay, and try to document them, and let's try to design them, how we would like to implement them in our application. So the first step here always is some design step. Let's forget for a little moment about the JavaScript object that we have for representing the data, and let's forget for a little moment how the structure of the SQL table is. Let's try to think about the abstract operations. Okay? And we can maybe describe, I have a README to populate, and say, okay, what are the operations that we want to support? For example, we may have the main entities. Entities are in this case two. We have questions and answers, right? And questions are mapped into a URL that we can call /questions/answers. In many cases, when you see real API servers, instead of having URLs like this, they have something like API version 1. Just to have a separate namespace for all the API endpoints, /API or something, and they tend to have versioning because if something is in evolution, you need to leave space for a new version if you need of the same API, instead of modifying the current ones because they won't work with new applications, okay, or with old applications. So there would be some sort of a prefix, okay, some common prefix to which we add that we can decide. Okay, maybe we have a prefix. It's just documentation here and not writing in any language, just to understand each other. Okay, so all the URLs we start with a given part, and then we'll go. And these questions is just a URI representing a question. What is the concrete representation of a URI? Of a question. That would be a JSON object describing all its properties. So the concrete representation would be represented by a JSON object like For example, we have the question ID. Oh, this is, yeah, it gets more or less right, not the answers, not the body, is the text, which was called. We don't, no, it's just plain wrong. We can pick into this function that we had last time, ID, text, email, user ID, date. So ID, text, email, user ID, and date. This is just the schema for the JSON representation of a question. ID, text, user ID. The user ID, we don't need to make it redundant, or if we want, we can also provide the email that we have in the object. There's no need that we have a one-to-one correspondence between the representations and the actual objects. It's something that we can also design. So what I'm doing here is every time we say that a method will receive a question or will return a question object, it means that I'm encoding it in this way. Then it's up to the client or to the server to convert this into an actual JavaScript object or into an actual data into the tables, into the database tables. And the same for answers. An answer may have an ID for itself, may have a question ID, the ID of the question that is linked to, the text, the user ID, and the date, for sure. And ID, text, image, ID, and the score. Copilot is dumb, okay? So this is the information that we use to represent an answer. So it would be a question object and an answer object. So we have the abstract representation. When we think about questions, or a given question would be prefix questions slash ID. Let's use the syntax with the colon so that we remember. It's a parameter. So we have this for the list of questions, this for each individual question, this for the list of answers, and there will be the same for the individual answer, again with the field ID, that in this case is the answer ID, not the question ID, of course. And then we probably also have users in the database. The exercise doesn't tell anything about users, so we are not asked to do any operation on them. But for sure, we need to read their names or read their emails in order to display them. So we need at least some read operations on them. There's nothing to ask us to modify the user list, okay? In this exercise. And so probably I have also some representation of users. So all the prefix slash users and users ID. And the user object is made of, let's see, let's copy the information. Okay, it's not there. He was in database. Okay, we didn't have any password yet. Okay, so these are some high-level representation of the type of entities that we want to manage. And what about the operations? What do we want to do? Okay, so let's say I want to, so does my application need, for example, about questions, to get the full list of questions? Yes or no? Does our application needs to get the full list of questions for a given user? Does our application needs to get the list of more recent questions? So I'm trying to imagine what I will need in the application. Now, maybe in the home page I have the list of the most popular questions or the most recent questions. Probably I will never need the full list of all the questions. So I try to list the operations that I need. Okay, I will need probably the following operation. Operation that the client, the user interface, will need from the server. So probably that would be a list of all questions for a given user. It will be useful in the profile, maybe when you log in you see your question and so on. List of all questions. In general, do we need it or not? I don't know. Maybe there are too many. Having an API that returns potentially 100,000 records is not maybe a good idea. But maybe, let's just say, listing all questions, all most recent questions. That could be useful, because we want to populate something on the home page, or the most popular ones, or whatever. So, list of all answers for a given question. Yes. Do we need a list of all answers given by users? Probably yes or no. Both yes. In my user profile, it's a bit of a mix because I have many answers to very different questions, so maybe useful. I don't know. I'm not so sure. Let's list it for a moment. Okay, we are creating our own to-do list of things that we need to implement. These are just the read operation. Read, let's say, as a verb. There's something that the server should provide to the client. And then operations. So adding a new question. So create a new question. With no answers, of course. Add an answer to a question. It's another operation. Vote an answer. We don't have scores or votes on the questions, only on the answers. What other operations do we need? Well, log in or log out, but let's not think about users, yes?
Maybe remove some answers or questions.
You want to delete a question or an answer? Yeah, can do that. So it can be delete one of my answers. One answer, which should be mine. Deleting a question. Which is quite not very nice because people already spent time to answer you and then you're deleting the question with all the answers related to that. Okay, not nice. I don't know. Not sure. Of course, now we are just imagining in the wild. Normally, for having the guidance of what operation we need, we should already have some specification, like we are doing in the lab. You already know what the application will do. So our question, your question would be, given what the application needs to do, what are the low-level operations that need to be supported? So it will be much easier to decide what is needed or not. Of course, be sure that the list will not be complete the first time. We will discover something, of course. Okay, so this is we decided what are the entities. So we are talking in this list only about answers and questions because they are the only concepts that we defined up there. What are the operations that we need to do, and then what are the implementations for those. So, for example, how to read the list of all questions for a given user. How do we represent it? I have two ways in mind. One would be a literal reading of this. So, read the list, get. All the questions for a given user should be questions like this. So give me the list of all with a query parameter, which is a query filtering, not just a note. These two have a very different interpretation. The first one is give me all the details of a question with this ID. So the ID there will be the ID of the question in the first case. In the second one, we have, okay, a parameter, a query parameter that describes what are we filtering on. We are filtering on the ID of the user. Let's not make the mistake of implementing the, okay, a given user, I give you the user ID, okay? Maybe I also write user ID here. But it's wrong, because this will be just a number. And the semantics of the number from the context is this the number of the question. I would never read this as the number of a user. Okay? And the Copilot also tried to, so this is wrong. And also this is wrong. Because I don't know what it represents. Very nice to have Copilot to find all kinds of wrong possibilities. It doesn't mean anything. Remember, our structure is collection, ID, relationship. In this case, we are joining two collections of how. And this is the idea of what. I don't even know whether I should return a user or a question if I see a URL like this. Okay? So it's clear that they return a list of questions. So get questions is the right way to go. But not all of them, only those that are for a given criteria. Another way to implement the same semantics would be to start the other way around. Get, thinking that questions and users are in a relationship with each other. So get users, ID of the user, in this case, of course, questions. Giving a user with this ID, what are his questions? I find it nicer. So I would go for the second one. It's clearer. And then, of course, we need to implement this. And it will return what? Returns, receives nothing, the ID of the user, and returns a JSON, of course, array of question objects. Now we just have to implement it. The list of all more recent questions is a bit more difficult, because get questions is not something that has enough meaning. I would put something like recent, like this, or get questions. Sorry, yeah, filter recent. Because actually being recent or not is not a real relationship, which is just a condition. So with a syntax like that, we could also imagine other ways of filtering. For example, from date, a given date, and so on. So we can imagine having a list of questions that usually must be called with some set of filters that we can define. Conceptually is the list of questions, but we don't want to return all of it. Okay? So this is more general because it allows for different types of filters. This may be more hard-coded if we are sure that we only want to specify that. Okay? I would go for the second one probably. And what does it return? It returns, of course, an array of, and then here we have two options of question objects, or returns an array of question IDs. So for example, the array would be 3, 74, 55, 1. Do you want to have the description? Go and seek them. Because we have the, yes, of course, I forgot to read the details of a single question. And in this case, it will be easy because it will be a get question ID. So I could have a first query that already returns an array of the object with all the information that I need. I need to call it only once, but it provides me all the results. Maybe longer, slower to transfer data. Or I decide only to give the minimum information, and then if you need more, ask me. So that would need that the client will need to make one call for the list and many other calls for the details. Maybe it's better the first one. If we are doing a startup of the application, I need to get the information anyway, so let's get it from the beginning. In other cases, maybe the client already has the information. If it's working, if the information was already loaded before, maybe I just need the IDs because I already stored or cached the description, so I don't need to read them anymore a second time. It depends, of course, on what do we need to do with this information. Okay, if I need to have all the information, it's better to have it all at once. If maybe some of them is not really needed, but maybe you just transfer some minimum information, and everything can be in between. Okay, maybe we have only the text and not the user. Okay, so we decide. We are in the phase here in which we are deciding, we are writing the specification, and then we'll just go for the implementation. Either way, the query will return the object or return the integers. Not a big issue. It's just of deciding when we still have the clear in mind the requirements of the application. Because later on, when we'll be debugging the queries in the SQL database, it will be difficult to reason at this level And so it's better to have it specified at the beginning. This is needed in any case, of course. But maybe, so it's also necessary, even if we have already all the question objects, maybe we click on a single. If the details, in this case, the question objects are small, they are just a text. No? But imagine having some field long, maybe you want to return only the ID and the title and the author. And because you will not display all the long text at once. Only when the user clicks on a given question, then you will load the long text for that specific question. Because the user will not open all of them, or not all at the same time. So it's, of course, a trade-off, no? That depends on the application. And the same goes for the rest. No? The list of all the answers for a given question would be some get all answers for a given question. So let's start from the question, find a given question, and find the list of its answers. And returns an array of answer objects that match. And the same is for the user. The list of all answers given by the users. You start from the user. Okay, in this case, Copilot got it right. The ID of the user, and then the answers that are thought as a relationship with the user. The type of object that we return is usually the last segment that we specify. Slash answers, we're returning answers. Slash question, we're returning questions. Okay, that's why this is nice, slash questions. And the other ones that we deleted are wrong. And then we go to the API that will modify the database. For example, create a new question, create a new item in a collection. Okay, this is the job for post into questions. And I'm giving a new I want it to receive by the way a new a full question object with the ID field. So question as an ID field. If I'm creating a new question, I don't know the ID. So how can I provide it to you? I can't. So with the ID field is missing or undefined. I'm providing you an object where the ID is not defined. Because only the database knows the number of the next ID. And therefore, the result will return the number, the ID number of the just created question. So I'm giving you the user ID, the text, the date, whatever. You process it, you insert the database will tell you, okay, I'm giving you this dot last ID, remember, in the SQLite API, and you return this last ID to the client that at this point knows how to call this object. This is one possibility. I return the ID number of just the question, or I return the full question object with the ID field now filled with the actual value. Actually, we are merging the old object with the new ID. This merge operation can be done on the server or on the client when you receive the ID back. The second case, it could be useful if you have more than one field to be filled. For example, the date. Of course, we don't know the ID of the question. We know the date in which it was posted, right now. But do we want the server to trust the browser to set the date in which a question was asked? If you are going to submit something at the exam, do I trust the data that you declare, or I will check the date from my own clock? Submitted 10 days ago. You are declaring that to me? Should I trust this information? So probably also the date is some information which the client should know, but the server wouldn't trust. Because anyway, the code running in the browser can be tampered by anybody. So when you receive some information, you should always be careful. Okay, maybe this information is generated by the code you wrote in your JavaScript. But there's no way of being sure that somebody on the browser opened the inspector and modified your code. Okay? Some extension, or some just modification, and so on. So if there's some information whose, let's say, original stamp should be certified, it's better to do that on the server. The server already knows. So maybe in this case, and also and the date field property will be ignored. Tell me what you want, I will recompute it myself. For example, And so, in this case, I will actually need to return a full object question with the ID field and also the date field updated by the server. So, this is the date I stamped. You can provide me your own, I override it. And I will tell you what it is, for example. So, the server is always sure that it inserted in its database, for example, the timestamp certified by itself. So we are actually, you see that we are reasoning in a mix of functionality requirements, what we need to do, something about performance requirements, how many information do we need to return, and something about let's not call security, but reliability requirements. How to put some, some countermeasures to attempts to modify our data, for example. Okay, and these two are always possible. I just return the ID. And if you want to get all the details, just call me the other method for getting the question. Or I already returned the full question. Maybe you just need the ID, or maybe you need the full object to display. Adding an answer to a question is again creating something new. So it would be a post, an answer to a question. So let's first find the questions. Sorry. Let's delete all of this because we need to. Questions ID, this is a question. Answers is the conceptual list of all the answers, the collection, the relationship of the collection of all the answers to the question. We add something to this collection in relationship to this question. So add an answer is not a post to answers, because then I wouldn't know which question it was attached to. It's a post to the answers in relationship to a question. So in this case, this method receives an answer object, then except where the field, the properties. So which are the properties that the server already knows about the ID, the date, like we said before, and the question ID. Can be ignored. Okay, inside my answer question, I have a field called question ID. Might be I need it internally for my JavaScript data structures. But the ID is actually already provided here in the query parameter. So I already know which question this answer is related to. And then the same information is also written into the answer object. Let's be explicit about which information wins. If the two are equal, okay. If there could be different, which one is the right one? The one that the server uses. Well, the server will use that in the URL, not the data embedded in the object, probably. So I could also, okay, the client, the web application knows which is the question that you're answering to. This field actually is ignored. It's already there, doesn't cost anything for the client to provide, but it doesn't need to be checked by the server, for example. Or we decide to do a double check whether the two are matching, for example. No? There can be something, some protective programming against bugs. Huh? And receives like that. And then what did I return? It returns, again, we are the same ID, the minimum amount of information is the ID of the just created answer, for example, or the full object with the date and so on. Again, also, sorry, and the score is ignored. I don't want somebody inserting a new answer and giving themselves a score of 25 already. The score should be given by others. So even if I set some score, the server will interpret as 0 and will save 0 into the database. So maybe our objects that are, comprehensive, they have all the possible, they're not used fully. No? In some cases, only a subset of the property are needed, of course, because we are dealing with partial data. We're building them step by step. So these are the general representation of the object. Some field may be missing, but the flexibility of JavaScript objects doesn't create any problem. The property is there or is not there, or we can add it later. So this is easy. Up to now, we have just used get and post. Post always in a collection, get either on a collection or on a single item. Voting an answer is something a bit different. Conceptually, it's not a get because we are modifying something. Do you think is a post? Is a put? Put means modifying. So I could imagine a put to an answers ID, and then I can provide receives an object, an answer object, with the updated score. So I have the answer, I am a client. I see that the score is 5, the user clicked on plus, on vote. I'm putting a copy of this object with the same values plus the score incremented to 6. Put overwrites the data, so the database would overwrite that. Or maybe just something like vote, so receives an integer value representing the updated score. I imagine a relationship vote. There is no vote, entity or table. but we can imagine representing that. So each answer could have an imaginary relationship with an abstract concept of votes, and I'm replacing that. So I'm not replacing the full object, but only the number. Okay? I would probably prefer the second one. It's lighter. We just give the number to update. But this is dangerous, because there may be, okay, so in practice would be, for example, put answers 3 vote, and then the body would be body would be 6. Why? Because maybe it already had 5 and the user voted, and so I'm overwriting the 5 with the 6. But if there are 100 people in this room that are clicking on the vote button at the same time, we will be losing some votes in this case, because everybody now is reading 5. And then if 2 people click on vote at the same time, both browsers of the 2 people know that the current votes are 5, compute 5 plus 1 equals to 6, and send to the server 6. And so the server will store that the new score is 6, even if 2 people voted. It should be 7. So updating a value requires to be sure that you have the updated value to start with. I cannot say, okay, the current votes are 5, are they? Or were they the current votes when I last read them? And in the meantime, did they change? Okay, so it's dangerous to send an updated value. It would be better to send the increment, the delta, and then the server will do the computation. And so the server will serialize the operation and will do the increments for every HTTP call that it receives. So I would prefer a post in this case of this kind. I'm giving you a new body, a new vote score, sorry, and the body could be just 1. It could also be ignored, it could also be empty. But I'm telling you, add a new vote. By the way, this also doesn't tell us whether the votes are recorded one by one. So with this new syntax, the server would also be able to save all the individual votes with the dates, and maybe with the user who gave them. Right now we only have a score, but it's not explicit here. I'm adding a new vote. If many users are doing the same at the same time, each of them just says, add one, and the server, one after the other, will process all the requests, and the cell will be incremented many times. And so maybe one browser, the user who didn't refresh its own browser, still has the old vote, the old score, but the database does have the real truth is in the database, which is updated without problem. So when we think about modifications, creating something new is not a problem. Modifying something requires reasoning about what happens with concurrent modifications. Different users in different parts of the world wanting to modify the same item. Okay? So the next step would be to start implementing some of them. I will not implement delete, which is against my religion, to delete anything. Because it's always dangerous. And so it's always better, if you want to delete something, my suggestion is have an extra field saying deleted yes or not, so that you never really delete from the database, but just set the field as deleted and have a view that only returns the one that is saying. Okay, so I nearly overrun my time, so thank you for today, and have fun in the lab this week.